Kotlin CLI tool. Build a command line application from scratch. Every developer uses command line tools every day. Git, Gradle, Docker, they all run in the terminal. In this video, you will build your own CLI tool in Kotlin. A text analyzer that reads files, counts words, finds patterns, and shows colored output. You will learn argument parsing, file I/O, text processing, and how to structure a real project. Good CLI tools have colored output. NSI escape codes add colors to terminal text. You start a color with a special escape sequence like \U001B31M for red. Then you print your text. Then you reset the color back to normal. We create a colors object with helper functions. Call colors.red with your text, and it wraps it in the correct escape codes. The colors object has constants for red, green, yellow, blue, cyan, and bold. Each constant is an ANSI escape sequence. The helper functions take a string and wrap it between the color code and the reset code. The reset code returns the terminal to its default color. Always reset after coloring, or the rest of your output stays colored too. Now let's build the text analysis engine. We create a text stats data class to hold all the results. It stores character count, word count, line count, sentence count, paragraph count, average word length, the longest word, and the top 10 most common words. Using a data class makes it easy to pass all these results around as a single object. The analyze text function does the heavy work. It splits text by whitespace to count words. It splits by punctuation marks to count sentences. It splits by double new lines to count paragraphs. Forward frequency. It uses grouping by and each count to count how many times each word appears. Then it sorts by count descending and takes the top 10. Kotlin makes text processing elegant with its standard library functions. The split function accepts a regex pattern. Filter removes blank entries. Map transforms each element. Grouping by with each count creates a frequency map in one chain. Sorted by descending orders by count. Take limits the results. This functional chain replaces what would be many lines of imperative code. For file I/O, Kotlin's file class makes reading files simple. File read text reads the entire file as a single string. File read lines reads it as a list of strings, one per line. We create a read file function that checks if the file exists and is actually a file, not a directory. If anything is wrong, it returns null instead of crashing. We also create a FileInfo data class to hold file metadata. It stores the file name, absolute path, size in bytes, and file extension. A separate format size function converts bytes to a human-readable format. It uses a when expression to choose between bytes, kilobytes, megabytes, and gigabytes. This makes the output much easier to read. Command line arguments arrive in the main function's args parameter. It is an array of strings. If the user types text analyzer analyze test.txt, args contains analyze and test.txt. We parse these into a CLI args data class with 3 fields, the command name, an optional file path, and a set of flags. Flags are arguments that start with double dash. To extract flag values, we write a helper function. Flags look like double dash word equals hello. The function finds the flag that starts with the given name and extracts the value after the equals sign. If the flag is not present, it returns null. This pattern handles optional parameters cleanly without complex parsing libraries. The analyze command is our main feature. It reads the file, gets file info, and runs text analysis. Then it builds a formatted report using buildString. BuildString creates a string builder and lets you call a pin line to add lines. The output shows file path, size, word count, line count, sentence count, and paragraphs. With the verbose flag, it also shows top words. The count command is simple like the Unix WC tool. It returns a single line with the line count, word count, character count, and file path, separated by tabs. The search command finds a word in a file and shows matching lines with their line numbers. It uses map indexed not null to process lines with their index and skip non-matching ones. The top command shows the 10 most common words with a visual bar chart. It calculates the maximum count and scales each bar proportionally. The repeat function creates a string of equal signs based on the word's count relative to the maximum. This gives the user a quick visual overview of the word distribution in the file. The main router connects everything using a when expression. It matches the command string to the write function. Each branch validates its inputs first. If a file path is missing, it returns a red error message. If a required flag is missing, it returns a helpful error. Unknown commands also get a clear error message. The when expression makes this routing clean. Good error handling is critical for CLI tools. Users need to know what went wrong and how to fix it. We follow 3 rules. First, check inputs early and fail fast. Second, return colored error messages in red so they stand out. Third, always tell the user what they should provide. For example, say please provide a file path, not just error. A key design principle is that every function returns a string instead of printing directly. This makes testing easy. You call the function, get the result string, and assert on its content. For file tests, use file.createTempFile to create temporary files. Call delete on exit so they get cleaned up automatically. Test both success and error cases. Another important design principle is separating parsing from logic. Keep argument parsing in one layer. Put business logic in another layer. Put output formatting in a third layer. This separation makes each part independently testable. You can test the analyzer without file I/O. You can test the parser without running commands. Clean architecture even in small tools. To run the tool, use Gradle run with the args flag. You can also build a distributable package with Gradle.zip. This creates a zip file with startup scripts for Linux, Mac, and Windows. The user can unzip it and run the tool from anywhere without installing Kotlin. For more advanced argument parsing, consider libraries like Clicked or kotlinx.cli. If you like this video, hit the like button and subscribe for more tutorials.